Hi, I'm replying to hi 81618J. I think that's the username that you have because I didn't catch what your name is. But you asked a good question here, and you asked for help concerning a specific propositional proof. And I took a look at your problem, and I think I can help you. Let me start off by writing out what the problem is. And again, I'm going to write each premise separately as a separate line. You had not, parentheses, F, then not K, therefore not X. The second premise here was you have X. The third premise is that it's not F and M. The fourth premise here is K. And the conclusion you're looking for, I'm going to write it off to the side here so that way it's clear, is not M or F. Okay. Now, the rules you're going to use here is the first rule you need to think about here is De Morgan's. And remember, De Morgan's rule says it's similar to algebra, but it's not in terms of when you have to factor in and out a negation or a negative. Where if I could, let me write down De Morgan's for you. Make sure right. De Morgan's rule says that, and De Morgan's rule is what we call rule of replacement, meaning that we can replace any portion of the line. So it says that if you have not P and Q, that is logically equivalent to saying that you have not P or not Q. Okay, and I think you need to use the first thing here as I see it is I see it. Whenever I see a negated parentheses with a conjunction, I always start off by thinking about a De Morgan. So let's do a De Morgan's right now on this, which means I'm going to sort of bring in the negation to both of these, and then I'm going to switch the sign, which means I'm going to end up with not F or not M. Okay, and that's line 3 De Morgan's. Okay, now as soon as I see, whenever I see a double negation, I have to remember the double negation rule. Double negation rule says that not P is logically equivalent to P, right? So we should clean that up too. So that means we're going to end up with F or not M, and that's line 5, double negation. Okay. Now that we've done that, the next thing I see is this X, because I think in your video you saw this too, is that this X you can use that if you double negate this X, you can end up with the modus tollens here. So I'm going to do that right now, right? So that's going to be not X, and that's line 2, double negation. And you can see I'm moving fairly systematically here. I'm not going to try to combine any two steps at once. But now that I have the not X here, I can now negate this. So I'm going to get with not F, then not K. Okay. And that's lines 1 and 7. Modus tollens. Okay. Now, as soon as I see the negation here, I might as well get rid of that thing and do another double negation. I think this exercise has a lot to do with double negation. So I'm going to end up with F, therefore not K. And again, I'm just going to use line 8, double negation. Right, I'm just getting rid of this and getting the P here. So line 10 here, okay, now what I have here, notice I have the K. Right, and notice if I could get, it's the same setup here as the X and the negation. I can use another modus tollens here. So line 10 here is to turn my K into a not K. Right, and so that's line 4, double negation. Okay, now that I have this, I can get the not F using modus tollens, right? Because this basically says that I don't have not K, which means that if I don't have the not K, then I must not have the F, right? So that's not F using 9 and 10, modus tollens, okay? And now let's go here. Let's see here. Now the next question here is, and so I'll scroll back here. I'll make it smaller at the end here. Okay, so now that I have the not F, the question is, take a look at here, line 6. I'm sorry, line 6 here and line 11, right? And here I want you to remember that we also have the disjunctive syllogism. Right? The disjunctive syllogism says that if you have P or Q as one premise and you have not P as another premise, you can conclude Q, right? So we're going to do that right here because guess what? It looks like we have that right here. I have an F or a not M. I don't have F, which means I must actually have this not M right here, okay? So that means line 12 here, whoops, suddenly I made my pen bigger. Line 12 here is going to be not M, right? Lines 6 and 11, disjunctive syllogism, okay? But now guess what? Now the difficulty of this problem is remembering that you're actually using the De Morgans twice, okay? So line 13, let's see what this is going to be. Notice that my conclusion here is a not M or F. Look at the De Morgan's rule here, right? Let's see here. Wait, hold on. Did I? Oh, I'm sorry. I didn't write. I only wrote there's two versions of De Morgan's, and I didn't write them both down. The other De Morgan's rule here. So that's one version of De Morgan's. The other version of De Morgan's looks like this. If you have not P or Q, that's logically equivalent to saying that you have not P and not Q. Okay. So I forgot to. I mistakenly wrote these. So De Morgan's is both of these rules. So maybe I'll highlight them. This is a De Morgan's and this is a De Morgan's. Okay. So let's go back here, because go back to this line. This says, right here is an M or F, a not. So that means that's basically this right here, which means if I can combine these two, I can convert it into this, okay? So let's sort of take a look here. And that's what I'm going to do here, because look, I have a not F and a not M. So I'm going to use not F and not M. And the rule I'm going to use here is the rule of conjunction. So I'm going to use 11 and 12, conjunction, right? And now that I've conjoined these two, notice I have this, I can convert it using the De Morgan's rule into exactly what this looks like right here. So line 14 is going to be not F or M, right? Not F or M, that's, let's see here. I'm sorry. Lines 12. No, I'm sorry. Line 13 De Morgan's. And then, of course, one little slip up here is that, right, ultimately the M needs to be on the other side. So I guess line 15 here is I need to use a commutation. So that means I end up with not F, or, I'm sorry, oops, let me erase that. Pardon me. Right, so I'm going to end up with not M or F, line 14, commutation. Because remember, a commutation looks like this, just to sort of give you the rundown. It's P or Q is logically equivalent to saying that you have Q or P, right? And since it's a rule of replace it, it means that I can just replace this with this and I don't lose any of my logical validity. And that's what I've done. This was my P and this was, I'm sorry, this was my P and this was my Q. And I just reversed the order and completed a commutation, which then of course leaves us with the conclusion. And so that's how you do those problems, do that problem in particular. It's a difficult problem, but here now you can see, here's the full proof that you are looking for. But you can see the trick here was to do this De Morgan's. That was, here I'll keep the color here, is you needed to do two different De Morgan's right here and here. And then you basically just had a lot of double negations, right? Here's a double negation, double negation, double negation, double negation. And then the rest here, besides the commutation, pretty simple stuff in terms of the basic mechanics of it. So I hope that answers, I'm sure it doesn't. I know it answers your question, but you know, it's kind of difficult, but again, if you see you can do something, do it. And, you know, take your book or your rules of replacement, rules of implication, and utilize them. And it really comes through practice ultimately. But I hope that answers your question. Great question. Great problem. Thanks a bunch, 81618J. Okay, talk to you later. Bye.